Hey, welcome back, everybody. Celeste, raise your hand.
Hi.
Max, raise your hand. Marcus, raise your hand.
Hello.
All right, good. Okay, hey, listen, we have an exciting topic today. Today, we're actually going to continue doing shapes, and we're going to move over to what is now areas of trapezoids, rhombuses, and kites. Okay, so with that, hey, Celeste, why don't you go ahead and get us started? Why don't you read the vocabulary term of trapezoid?
Trapezoid, a quadrilateral with one pair of parallel sides.
Oh, awesome. Okay, so you're guaranteed that with the trapezoid, there's going to be two sides that are going to go in the same direction. Notice how these other sides do not go in the same direction? That's the reason why this is known as a trapezoid. Okay, good. All right, hey, Marcus, why don't you go ahead and read the next one, which is a rhombus.
A parallelogram with 4 equal sides.
Excellent. Okay, so can a rhombus be a square?
No,
Only sometimes.
only sometimes.
Only sometimes, yeah. Okay. Max, why don't you go ahead and read diagonals?
A segment joining two non-consecutive lines. I'm not sure if I guessed that right.
Non-consecutive vertices. Yeah, so, hey, let me go ahead and clarify this because some people, okay, so you see this vertice? You see that vertice? Okay, those are consecutive. That means they go one after the other. So we want something to be non-consecutive. So there's an example of non-consecutive. So you see how there's a diagonal right here? So it's a line, it's a segment that joins two non-consecutive. Okay, great. Let's go ahead and scroll down. And let me go ahead and get, let's see, ooh, I think I went too far. Let me see if I could move this a little bit better. All right, excellent. All right, so let's say, go ahead and read the next one. Read the area of a trapezoid.
The area of a trapezoid is half of the product of the height and the sum of the bases.
All right, excellent. So in very easy terms, I'm able to guarantee you that if you add the two bases and you multiply by the height, and then you multiply by half, you're guaranteed to get the area of a trapezoid. So easy formula, maybe new for some of you. Now, Marcus, go ahead and read the next one for us. Read the area of a rhombus or kite.
Okay. The area of a rhombus or a kite is half the product of the length of its diagonal.
All right, excellent. So this is easy to use. The only thing you really got to do is just find the area of each diagonal. Like, not the area, but the length. So you see, like, I did that length. And then see the blue one, you do have the other length. So you just do that and you multiply them together and multiply by half and you get the solution. All right, excellent. Let's go ahead and get into our examples. Now, Max, go ahead and read the example 1. What does it say? Yeah, I think you're trying to say find the area of each trapezoid. All right, excellent. Okay, so Marcus, Max, lead us through this. How would I find the area of this trapezoid? All right, Max, I think you're breaking up on us. Did you hear me? Okay. Hey, Maximus, why don't you go ahead and go, why don't you go upstairs? I think you have bad reception where you're at because you're coming in choppy, okay? So Marcus, why don't you take over? How would you do A?
First add base 1 plus base 2 to get a total 36.
Okay,
then
good.
Divide 12 by 2 because you know it's height times 1/2. So that would give me 6. So it'd be 36 times 6 to give us 216.
216. Excellent. All right, excellent. Okay, good. All right, Celeste, why don't you go ahead and do the next one for us?
Okay. So you would do 14 plus 6.
Okay.
And then 5.5.
Okay. So you do, so remember B1 plus B2, and then you will get the height, and then you multiply, so it will look like this. You start with the formula, 1/2 base to 2 bases times the height. So 14 plus 6 times 5.5, and then as a result, we'll get 55. All right, Marcus, go ahead and do the next one.
Okay, so we would add the bases, which is 8 and 3, to get a total of 11.
Okay, good.
And we would times it by 55 to get, 5 to get 55. Then divide 55 by 2 to get 25.25.
Oh, 27.
27.5.
All right, excellent. All right, good. Okay, so now let's go ahead and move down. And all right, so let's read the directions on this one. What does this say?
For example 2 or for D?
D. I'm looking for D.
Okay. Find the area of a trapezoid with bases 16 inches and 7 inches and height 9 inches.
All right, excellent. All right, so lead me through this. How would I solve this?
Well, you would do 16 plus 7.
Okay, so we'll do 16 and then we'll do 7. I ask you to go upstairs so you get better reception, but it's okay. And then where would we place the height at?
By the things, well,
Yeah, you want to
it's
find
right
the
there.
distance, yeah, from there to there, right? So then that's where we're going to place the 9. So let's see, let's put 9 there. So now that we have 9, what would you do then, Celeste?
You would
So
do
at the basis.
23 times 9 is.
Mm-hmm. So then, you go ahead and just use it in the formula, and then you get a result 103.5. All right, good. Okay, Marcus, why don't you go ahead and read example 2.
Find the area of each figure. If your answer is not an integer, leave it in the simplest radical form.
All right, excellent. So in this case, you're going to use your calculator, but not if it's a radical. You're going to do everything else except it. All right. So Marcus, how will we solve A then?
Okay, so you do 14 plus 30 to get the second base.
Okay, I think you jumped a little ahead. How did you get to 30?
Well, I just added 14 plus 16.
Yeah, excellent. Okay, so you added the 14 and 16, so you added the whole base, right? So you made the discovery, you did the line, that was 30. And then what would you do afterwards?
Afterwards, I just added that to 14 to get 44. Then, well, I'll divide, the next step I would do is divide it by 2 to give it 22, which is then, since we don't have H, it would just be 22H.
Well, I think the thing they're going to want you to do is that, hey, take a look at this, Marcus. Tell me, does this remind you of anything, this triangle right here?
It's a right triangle. Oh,
it's a right triangle, yeah. So
you
you use Pythagorean theorem. Yeah.
Yeah.
So as a result, we'll do this. H squared plus 16 squared equals 20 squared. We'll subtract 16 squared, then take the square root, and as a result, we'll get H is 12. And reason being, this is 400. I think this is 16 I think it was 256. So as a result, you get the square root of 144. That's a perfect square, so you get 12. Now, once we have that solution, Marcus, then you have the missing puzzle, the part that you were trying to, I think, figure out. And because you know how you discovered the other base already? So pretty much from there, it's clockwork. You do 1/2, base, 2 bases, 264. All right, excellent. Okay, now, Celeste, why don't you lead us to this one? How will we do B?
Well, Daddy, I was a bit confused with the A.
Okay. Well, when it's up happening, okay, Mom, and let me go through it again. That was height, right? Okay. To get this height, there's this famous theorem called Pythagorean, which is this one here. And that theorem gives you the ability to actually solve for H. Now, so that's H. This is base 1. And then these two added together will give us base 2. So base 2 came out being 30. So once we have these 3 things, so you see how 30 is here? That comes from here. Our 14 for base 1 goes into here. And the hardest thing to discover was that 12, which was a height that came from Pythagorean theorem. That was Pythagorean theorem right there. Okay?
Whoa.
You know, you're not yet there to learn this yet, but one day you will. Okay? So for the moment, we'll help you through those parts, but I want to say that the next one does not require Pythagorean theorem. So why don't you go ahead and lead us to how to solve this one, Celeste?
See?
No, for B. What you gonna do B next?
Well, so we're gonna need the base, which is 30.
Okay, so the other base is 30, good. So that top one is 30. And then what else?
Because if they're parallel.
Good, so continue. Now how would you find this base right here?
Well, from the 6, that's
And the
60.
30. No, the 6 and the 30 you're gonna add together to give you 36.
Yes, that's
so
what I
give
meant.
You the total. Yeah. So then you have the two bases and you have the height. Now the only thing that is gonna be new about this one is that remember they wanted us to leave it in the simplest radical form. So in this case, once we start solving for this one, so we got our things, see what we got here? Okay. We're gonna leave that one alone, Celeste. Actually, let me do it in yellow. You see the square root of 3? We're gonna multiply all the other numbers and do the PIMDOS with them. Like we're gonna add these two first, 30 and 36, and then multiply with 6 and then divide by half. See, so you see how I got 198 right here? Okay. Remember we left that alone, and as a result, you could get you could simplify it, but we're going to leave it in the simplest radical form, which is there. So there's both solutions. Okay, good. All right, Marcus, why don't you go ahead and lead us to the next one? How will we do the next one?
Okay, well, you have a rectangle and a trapezoid, so let's go get the easy stuff out first.
Okay.
So
good.
4 times 8 is 32, so we know the area of the rectangle is 32.
Okay, good. And then what about over here?
This little weird part. So you would have 14 times, you would have times 8, no wait, you would have 8 plus 14, sorry, which would give you 22. Then you would times that by 4, divide all that by 2.
Okay, excellent. So then you'll get as a result 76. All right, excellent. Okay, good. So now let's go to the next page. All right, so let's read the directions.
Find the area of each kite.
Excellent, Celeste. So lead me through. How would I find the area of this kite?
For A, for this kite.
Okay, well, let's start with the equation, Celeste. So you see how it says 1/2 diagonal 1 times diagonal 2? Okay, so tell me, Celeste, what is the measurement of this diagonal right here?
That is 12? No.
You're right, it's 12. And what's the measurement of this other one right here? For the diagonal I just drew. No, actually that's going to be 6 plus 6. So it's 12. Also 12 as well. So once we have the two diagonals, we're going to have 1/2 12 times 12. So as a result, we'll get 72. All right, good. Hey, Marcus, lead us to the next one. How will we do the next one?
Okay, so you do. Okay, so you'd first want to find the area of both the length of both diagonals, which would be the longer one would be, what is that? 22?
Well, actually, that one just may be 14.
16.
Oh no, it's actually 22 and 16. You're right. How'd you come up with the 22?
Well, I added the 14 one and then the 6 one, and then the 8 one. Sorry.
Yes. So that one, since it was pointing here, you added the 14 and the 8, so this one was 22. And then let me make the other one in red. This one was 16, right? So that's how you come up with those values, and then afterwards, you get 176. All right, so let's go ahead and solve the next one. Let's see.
Okay. So if that's 4 and 14, we will get 18.
Good, so 18 for this red one. Oops, let me try to do that a little bit better. There you go. Okay, and then the other one?
is 14 because 7 plus 7 is 14.
All right, good. So then we have two diagonals. And as a result, we just do the math and we get 126. All right, good. Now let's go ahead and scroll down. Okay, now, all right, Marcus, why don't you go ahead and read the directions for example 4.
Example 4.
Yeah.
And the area of each rhombus.
Excellent. All right, so Marcus, how will we solve this one?
Okay, for A, you just do 12 plus 15 and 12 plus 15 to get both diagonal lengths, which is 27. Then you do 27 squared, which
Well,
is
I
a
think
big
you're
number.
thinking
I don't
about this
know.
wrong, Marcus, because see,
What do you mean?
you see these are both 12, so this is 24.
Oh, sorry, yeah, you're right.
And then this one's going to be then 30. And one of the benefits that we have is that one of the things that we're able to guarantee is that the equation stays the same for rhombus. So you got 30 and 24. So as a result, we get 360. All right, so let's lead us through the next one.
Okay. So the next one, the line for
This
that will be
line,
9.
she's going to be 6, because 3 and 3.
Oh, right, 6, I assume multiplication, I'm sorry.
No worries.
And then
Yeah.
8.
Yes, 8. So, oh no, actually no, it won't be 8. Why is it not 8?
Because it's just the square root of 7.
Yeah, it's a square root of 7, and it's actually written in there. But you see the 4 and the 3? If I did diagram theorem on this one, let me try to do it. Let me hold the screen. We basically have one of the legs is missing, so let's call that a squared plus 3 squared. Oops, hold on a second. It's not liking where I'm writing it. Let me modify that. So like if you have a squared plus 3 squared is equal to 4 squared. We'll have a squared is equal to 4 squared minus 3 squared. So then you'll get a squared is equal to 16 minus 9. A squared equals 7. And then lastly, you got to take the square root of both sides. So a is the square root of 7. So this is a square root of 7 plus the square root of 7. So guess how many square roots of 7s I have, Celeste?
2.
Yeah. So as a result, the diagonal, okay, so we know that the one in purple, 6, right? The one that we're going to make in red, that one is going to be 2 square root of 7. So let's see how they do it down here. So they went with the Pythagorean theorem. And you see how they came up with 2 square root of 7? Well, remember, they left everything in the simplest radical form. So that means that this part here, one of the benefits we did is that that part did not get changed. That part stayed the same. It didn't get affected. You just multiplied the 6 and the 2, which is 12, divided by 2, which is 6. All right. Now let me erase some things here. Marcus, why don't you go ahead and lead us through the last example of this?
Okay, so we don't have to use Pythagorean theorem for this one. To find the longer one, we just do 8 plus 8, which is 16. And for the shorter one, it's 6 plus 6, which is 12. So then it's 16 plus 12 times 12, which is a big number.
You're going to be surprised, Marcus. I think that it was written in for you, but you actually had to do Pythagorean theorem to figure out that that was actually 8. And then you do exactly everything you said. 12 times 16, that's about that half, is 186 as a result. I think that's it for this one. Let's see. Yeah, that's it. All right. Well, thank you, everybody. Thank you for joining us again. Go ahead and study these notes, the assignment, and I look forward to the next episode with you guys. All right, take care. Everybody say bye.
I love you.
I love you too, man.